Hello everyone, welcome. My name is Suyash Chandolikar, and today we are going to learn what is serial and parallel processing and Flynn's classification. So, serial processing. What is serial processing? It is a type of data processing that involves executing tasks or operations one at a time in sequential or linear order. In other words, each task is performed one after the other, and the output of each task becomes the input for the next one. In serial processing, only one operation is performed at a time, and the processing time for each task is fixed. The completion of one task triggers the next one in a predetermined sequence until the entire process is completed. This approach, often used in situations where the task must be completed in a specific order, or the output of one task is required for the next task. For example, if we have a program that needs to read data from a file, we perform some calculations on that data and then write result back to the file. It would use serial processing. The program would read data from the file, then perform calculations, and then write the results back to the original file in a predetermined sequence. Each step would be completed before moving on to the next, ensuring that the output is correct. While serial processing can be reliable and easy to implement, it can also be slower and inefficient while dealing with large amounts of data or complex tasks. Therefore, it is not suitable for situations that require high processing speed or real time performances. It can be useful in situations where the task or instructions are simple and do not require a significant amount of computational power, or where parallel processing is not possible. However, in many cases, parallel processing can offer significant advantages in terms of speed and efficiency, which will be explained in the next part by my teammate Swayam Chandak. Thank you.
Let's talk about parallel processing. Parallel processing is a technique used in computing to divide a large task into smaller subtasks that can be executed simultaneously on multiple processing units, such as CPU cores or GPUs. The goal of parallel processing is to increase the speed and efficiency of computations by distributing the workload across multiple processors, which can perform the task at hand in parallel. Parallel processing can be implemented using different techniques such as multiprocessing, multithreading, and distributed computing. Multithreading is a technique that enables a single CPU or CPU core to execute multiple threads simultaneously, which can improve the performance of applications that are desired to run on multi-threaded architectures. Parallel processing is used in various applications such as scientific simulations, weather forecasting, machine learning, and data analytics. It can significantly reduce the time required to complete complex computations, allowing researchers and scientists to perform simulations that were previously impossible or impractical. Now, the next topic will be explained by my friend Chandrashekhar.
Now we are discussing about the difference between serial and parallel processing in computer architecture. The main difference between serial and parallel processing in computer architecture is that serial processing performs a single task at a time, while parallel processing performs multiple tasks at a time. In serial processing, same tasks are completed at the same time, but in parallel processing, completion time may vary. In serial processing, data transfer in bit by bit form, while in parallel processing, data transfers in bytes form.
So now let's start with Flynn's classification of computers. Flynn's classification is a method of categorizing computer architectures based on the number of instructions, streams, and data streams that can be processed simultaneously. It was introduced by Michael Flynn in 1966. MJ Flynn offered a classification for a computer systems organization based on the number of instructions as well as data items that are changed at the same time. An instruction stream is a collection of instructions read from memory. A data stream is the result of actions done on the data in the processor. Overall, the Flynn's classification provides a useful framework for understanding the different type of computer architectures and how they process instructions and data streams. The term stream refers to the flow of data or instructions. Parallel processing can happen in the data stream, the instruction stream, or both.
So,
The topic now we are going to see is SISD and SIMD. So what is basically SISD and SIMD? SISD stands for Single Instruction Single Data Stream. It is a type of computer architecture in which a single processing unit executes a single instruction on a single data item at this time. This type of architecture is commonly used in simple microprocessor and embedded system. It is a uniprocessor machine capable of executing single instruction. In SISD, the processor executes instructions sequentially at one time on a single data item, as you can see in the shown diagram. Therefore, SISD architectures are not suited for high-performance programs applications that requires massive amounts of data processing in parallel. Now, the second topic we are going to see about is SIMD. SIMD stands for Single Instruction Multiple Data and is a type of computer organization in which a single instruction is executed on multiple data items simultaneously. The SIMD is a multiprocessor machine capable of executing same instructions on CPU but operating on different data stream. This is basically what just it is, that it is a multiprocessor machine that converts multiple datas into a single instruction. In a SIMD processor, the processor contains multiple processing elements that can execute the same instruction on multiple data items in parallel. This can lead to significant performance gain compared to SISD architecture, as multiple computations can be performed simultaneously. SIMD instructions are often used to accelerate performance in tasks such as image and video graphing, audio processing, etc.
So the next topic is MISD, Multiple Instruction Single Data Stream. So MISD is a type of parallel computing architecture that allows multiple processors or processing elements to operate on the same dataset simultaneously. In an MISD system, each processor can execute on different instructions on the same dataset. This architecture is less common than other parallel computing architectures which we have seen earlier like SIMD and MIMD, but it can provide fault tolerance. However, this approach can be complex and expensive. MISD systems are typically used in specialized applications such as military and aerospace systems. So the next topic is MIMD, multiple instruction, multiple data streams. So MIMD is a parallel computing architecture that enables multiple processor or processing elements to independently execute different instructions on different datasets simultaneously. MIMD systems offer improved performance and flexibility compared to other architectures like SIMD and MISD. They are commonly used in high performance computing applications such as scientific simulations, data analytics, and ML, where processing large amounts of data in parallel is essential for achieving faster results.